Hello and welcome everyone. So about a month back, I made a video about dangerously smart agent, and it was a kind of catchy name that I had picked. There's nothing dangerous about this agent. It is just a code generator agent that pre-processes request and generates the code, but does it in a very smart way. And it is smart enough that it can be categorized as a dangerous agent. However, I realized that while I was coding this agent, I had picked up a model that was very strong model. I had picked up a 70 billion parameter model. And in that model, you have a lot of wiggle room essentially. Like bigger models are very smart. You can give it a request and it kind of understands automatically what you want to do, most of the times at least. So if you want to use this dangerously smart agent for a smaller model, something like Llama 3.2, then you probably will fail. It will not be able to process it good enough. So what I've done is in these few days that I've been off, what I've done is I've converted this particular agent, the dangerously smart agent, into a Llama 3.2 compatible, format, if you want to say that. So what I've been doing is enhancing the prompt essentially and making it compatible with the most recent LangChain's chat ollama instead of using the ollama function. So there are two major upgrades over here. One, the the ollama functions has been replaced with chat ollama, and two, there is a huge update in the prompts section that I'm gonna go over today. So let me give you a high level overview of what this particular agent is. So imagine you have a request. You have a request where you want your smart AI agent to do something. You want your agent to, let's say, create a program for generating prime numbers, right? And this particular agent framework, the DSA framework, let's refer to as DSA, Dangerously Smart Agent Framework, it will pre-process your request and then it will generate code and it will extract code, validate code for its correctness, and perform a code review on it. And if the code review is successful, then it will execute that particular code in a Dockerized container in the Dockerized environment. And if you want to see in more detail about this particular concept, then I've done like an hour-long video over here, and it goes over in detail about what this dangerously smart agent is. In today's video, what I'm going to do is create some enhancements for this DSA so that it is able to run on a smaller model. So in order for me to do that, let me show you the shortcomings of the previous model or the previous agent. So let me go over here, and what I'll do is, let me see. I'm gonna bring this particular terminal over here, and what I'll do is I'll revert back to October 13th, which is when the video was published, right? I think around October 13th. It's not showing the date over here, but this is 1 month ago, October 13th, right there. I don't know if you guys can see it, but it is October 13th. So let's go back to October 13th. This is the commit that I had. So do a git checkout, and let's get this commit in, and let's do a cd to LangGraph dynamic agent, and let's take a look at how this looked like at that point. So you can see that I had ollama functions being used over here, right? And I was using Llama 3.1 70 billion parameter model to process this particular agent request, right? So let's do that. Let's go to our AI server, which is in my basement. So this is the AI server. If you can see, this AI server has 4 GPUs, 4 NVIDIA 3090 GPUs. And if you want to see what this server is, I have a video in the description. I'll post the link to it with the details of this AI server build. So let's run this particular dangerously smart agent on this quad NVIDIA 3090 rig with the prompts that I had over here. So you'll see the prompts are very simple right now. For example, the preprocessor agent just changes the initial prompt, which is if you are asking what is the system time, then it changes it to generate a Python code to get the current system time using the time library, right? So these are some of the few short examples that I have provided where you can ask or give suggestions to the large language model to generate the requests in this way. So if you have a request like how can I calculate the square root of a number, right? This is the initial request, and the agent will change it to generate a Python code to calculate square root of a number using math library. So these are very simple kind of pre-processing of the requests that is being done. And this is why, like even with these simple pre-processing requests generated, let me show you. So this preprocessor agent generates these simple pre-processed requests, right? So this is your question coming in, and this is what the preprocessor agent's response is coming out. And then if this is your question, then this is the output response coming out of it. So preprocessor agent isn't really doing much over here, and this is what the main shortcoming over here is. But let me show you what this looks like. So let me execute this code. So let me do so I'm already in the conda environment of LangGraph over here, and let's do Python. And I think this is in the workflow LangGraph agent. So this is where the execution starts. Workflow LangGraph dynamic agent.py. And it's already asking me to not use the ollama functions, but actually use chat ollama over here, right? So what is it saying? Let's see. Ollama call failed, status code 404, maybe a model is not found. Okay. Okay, so Llama 3.170 billion parameter isn't even there anymore. Okay, all right. So let me go ahead and change my AI Llama 3.1 to, let's say, Nemotron. I know I have Nemotron over there. And Nemotron is a very good model. It's a very, very, very good model by NVIDIA. So let's just run this again. Nemotron, oh yeah, Nemotron isn't 70 billion, it is just latest, so I need to just remove that. And let's run this again. And now it is executing. So you can see it is going to 11434 server over here. So it is loading the model on these two, appears to be. Yep, so on the top two GPUs, it's going to load this model and pre-processing the request, and it will do a good job at it. So once the model is loaded, the subsequent requests will be faster, but the very first request will take some time because it is actually loading the model over here. All right, yep, so the model is loaded now, and it is, so see, the very first question was calculate the factorial of 10 and generate Python code to calculate the factorial of a given number 10 utilizing math library or implementing a recursive algorithm approach. And then it it actually bombed out over here. Okay, all right. All right, let's have it process the next request. So in the next request, let's see what the next request is. So let's come down over here. And the next request is in the workflow LangGraph. So these are the requests. Generate Python code to calculate square root of 144. All right. So pre-processing, and this is the preprocessor agent result. Generate Python code using math library and all that. And then it is attempting to generate the code now. So it is in the step number 2 now. It has pre-processed the request, right? So it has bombed again. So it looks like ollama functions is actually, it looks like it is not working anymore. So this was actually a experimental feature, and now you can see that ollama functions isn't working anymore. All right. So step 1 is that we need to change the ollama functions to chat ollama, because it doesn't look like it's gonna work anymore without switching it to chat ollama. Ollama functions was really awesome. I absolutely enjoyed using ollama functions. I don't know why they removed it. They must have had a very good reason, but they have already removed this. So this brings us to our very first upgrade that we need to do, which is what I'm going to show you over here. So I've already um, added the ollama functions over here. There you go. So replace ollama functions by chat ollama, and this is the one that I will check out now. So let's do a git stash and get everything out, and then git checkout of this particular code, and you will see that the biggest change over here is that we are not using ollama functions, but we are using chat ollama now, right? So let's do that. And while we are using chat ollama, we will let's switch to the AI server again. Let's switch to Nemotron model again, and let's switch to Nemotron model over here too, and the AI server over here too. Okay. All right, and let's execute this again. So the only change that we have done, or almost the only change that we have done, is switched the ollama functions to chat ollama over here. This is the biggest change that we have done, and let's go ahead and let's run it. I want to show you that in the prompt there isn't much change over here. This is the biggest thing that we'll be upgrading later on in this video, but up until now you will see that the prompts.py remains exactly same, and we have only upgraded the ollama functions to chat ollama, which is the recommended approach for LangChain. All right, so let's run it again. Workflow dynamic agent.py using Nemotron model, and it's already loaded over here, so it would not have any problem. And let's see, so it is pre-processing user request, so which means it is, let's see over here, it is at this stage right now. And you can see the model is working hard by processing it on these two GPUs. All right, very soon the model's pre-processing will be done, and we'll be moving on to the next step of code generation. So anytime now. So Nemotron model can be a little bit chatty sometimes, so pre-processing the request does get longer, because these are not streaming results. These are actually the results coming directly as an output once the whole result is received and processed. So let's see, let's wait for a little bit more, and let's see once the results are back. So there you go. And this is awesome. This is exactly what I wanted to show you. Like, see, in Nemotron model, it nicely puts the whole functionality over here. This is really awesome. You can see that even though we gave a hint to the model to, in the prompts, use an output, like a simple output like this, generate Python code to get the current, weather and time or whatever. But if you see how nicely this big model actually created the output for us, right? This is the preprocessor result. This is awesome. It put down the whole functionality. It said like mathematical operation, required libraries, output handling, input validation. And this is the reason why if you have a big model like Nemotron, it generates a really good quality code. So the preprocessor agent has already done enough of the work. It has given good suggestions to the code generation agent now. The code generation agent will just follow the preprocessor agent's guidelines, which is huge. These are very good and nice guidelines over here for us. So preprocessor agent is now acting as like an architect agent over here. It has become an architect, a system architect, which is giving more detailed guideline and hand holding. And this is where the smaller models lack. Like if I had asked a smaller model to do exactly same thing, it would not have generated a good pre-processed request for the next agent, right? So let's see. So now that the first agent has requested the second agent to generate the code after providing the pre-processed request, this is the code that was generated over here. And in this code, you can see that it's a very nicely written code that's nice. And calculate the factorial of 10. Preprocessor agents was this. Generated code was this. And extracted Python code. Extracted Python code will be down here, right here. Because I'm printing the agent state, the whole agent state, and you can see this in the previous video that I have posted. Because I'm printing the whole agent state, only when the state is populated, it gets printed over here. And this is the extracted code. Look at the quality of the code. The quality of the code just for writing a factorial is nice. It's really nice. And its niceness is coming from the preprocessor agent actually doing its work. So if you go down now, you'll see that the code review agent is reviewing the code now. And after reviewing the code, let's go down and see the code review result. And such a nice code review result. See, the code correctly calculates the factorial of a given integer. It meets all specifications, uses pure Python functionality without unnecessary libraries, handles input validation for integers, and edge cases, negative numbers, and all that, which is pretty awesome. So code review result status continue, and then we go and we execute this, and then we will get the final answer over here. For 120, the final output is 362 8800, whatever. So why were we able to achieve this? We were able to achieve it because of the huge Nemotron model. And if you guys can see, Nemotron model took 22 plus 22, so like 45 gigs of VRAM for these two 3090 GPUs. And I mean, I have the luxury of having 4 NVIDIA 3090s in the basement server and 2 NVIDIA 3090s in this particular machine that I have. So 6 of them over here, but not everyone will have this luxury. So I tried to change this, or actually the challenge was to see how can we use a small model to do this task. And let's see if a small model can even do this task. So I'm going to do a Control-C exit out of this. Right? Let's just switch it out to a smaller model. So from Nemotron, let's use Llama 3.2, and it's going to use the 3 billion parameter model. Llama 3.2. And once we do this, let's see if the 3 billion parameter model can handle the same request or not. So now we're going to run Llama 3.2 over here and see I mean, maybe it will work, but you see, calculate factorial of 10, preprocessor agent result, generate a Python code to calculate factorial of a number. And maybe it did work in this instance. It was able to create it. It did a decent code review, right? Not bad code review, but it was able to do it. I have to give it that. You know what? Let's continue with a second request and see if it's able to do that. Yep. So it was able to do the second one too. Look at the speed of 3.2 though. I mean, it's really awesome. The third request, and it's able to generate the code for third one too. Speed is really nice. Fourth request, and it was able to reverse the string and that's also awesome, even though like it is not doing good enough code reviews for us. It is still working, it's kind of working, so it makes you believe that it will work for maybe all the situations and instances. But let's continue, let's see if it breaks or not somewhere. And it worked over here too. Let's continue with one more, and it worked over here too. And let's continue over here again. And it worked over here as well. And worked again. And worked again. So it is doing its job over here. Somehow it is doing its job. It's proving me wrong. It's doing its job right now. However, if you see, there have been instances where sometimes, even though it creates the code isn't as good quality code over here, because the code review agent, sorry, the preprocessor agent didn't really give it a very good direction. The point I'm trying to make it is that if the architect is not good enough, if the architecture of the whole system design is not good enough, then maybe the code that your developers will write won't be good enough either. So what we want to do is make sure that top down, when the request comes in from the functional analyst, right? So when the very first agent receives the request from some kind of functional agent, right, which is the user is asking the very first agent to do something, then this first agent actually acts as an architecture agent, and this is where most of the decision making can happen over here. So instead of just having a very simple pre-processor of the request, we can actually convert this into an architecture agent, and this is one of the main differences that can change the quality of the code that is being written. So if we see some of the codes qualities, let's go up and look at some other pieces of code that it has written. For example, take a look at this, right? I mean, a very very basic like code that it has written. No, there is it just doesn't look nice. It just doesn't look nice. Maybe it is functional in this instance, but it may not work when we provide it a little bit more complex requirement. And Llama 3.2 is a good model. It's a good code generation model too, but it isn't it isn't as good. If you have used it, you must have notice that too, that it is a decent model, but it is not very good model. I'm trying to get to a situation where the model breaks, because I've seen that even with my requests over here. Many of these requests were too much for this model to actually generate the code for, or it was generating the code but it wasn't generating a good quality code one way or the other. Okay, so enough said over there. Let me now show you what can we do to actually enhance the quality of our prompts, right? So this is where the prompt engineering comes into picture, and we change the role. We'll keep the name as the preprocessor agent itself, but we will change the prompt for the preprocessor agent. And just by changing the prompt for the preprocessor agent, even the Llama 3.2 will start writing good quality code over here for us. So let's do that. I've already changed the prompts. Let me check out the latest code over here. So this is the git commit. So let's do that. Git stash so that we can get all that away, and then git check out main, and let's take a look over here. Let's see the changes. So the changes that we have done. When we ask, so I'm looking at the prompts.py file, right? This is the biggest change that we will see over here. So in the prompts.py file now, when we are asking the user request, this is the first functional requirement that we are getting. So we've been asked, hey, calculate the factorial of 10. And we're asking the large language model to respond back exactly how Nemotron was responding back, right? So we have asked it to say that, hey, this is the functionality. These are the few shot examples over here, right? So only one few shot or one shot example I have provided. This is the functionality. This is the input. This is the operation. This is the library or the module that you have to use. This is the output. And then some specific requirements that we have provided, that you need to make sure that there are any errors or any validations that you have to do. So make sure that you're doing all those things too. And we have held the hand of the large language model almost and made it aware that this is how you have to write the code, right? So now if we do that, we can utilize the Llama 3.2 model again and see, is it creating some good quality code for us or not? Let's see that now. So we'll now, let's switch it back to AI. It goes to the basement server. And then we will run the same command again, Python workflow, LangGraph dynamic agent.py. Okay, all right. Now when we run this, you'll see that it is pre-processing user request, and the preprocessor agent in an amazing way becomes an architecture agent now. And you will see the quality of the code that will be generated now is awesome. It is generating really nice quality code. It is checking for error. It is doing the try catch over here, and then it is providing the code for us. This is such a nice quality code that it has written. Let's get down and let's go to the second part over here. You see the code review is also kind of okay. It's an okay code review. Um, let's go down and let's go to the next example. So in the next example, let's see what the request was. So the request was generate the Python code to calculate the square root of 144. And see the preprocessor agent acting as an architecture agent over here. Functionality, input, operations, library, and output. Right. So really nice guidance it has given to our large language model. And see the same code, it has been written in such a nice way now, like cleaner, nicer, error handling code. It really makes me feel good about the future of AI. All right, so let's keep going forward. I want to go to the one where it has generated I think the area of the circle. So I believe it's in the next one, so not in the Celsius, but even this one. See, take a look at this code. It was such a simple code to generate or convert Celsius to Fahrenheit. And with all these requirements that it has written, the preprocessor agent has written, it wrote such a nice code over here with all these exception handling and all that, right? So it is pretty cool how it has done this. All right, I want to go to the request where the circles area or whatever was being generated. Let's see if we can reach over there. I think it is the next one, or yeah, there it is. So circles area, create a function that calculates the area of a circle given the radius, right? And this is the functionality, input, radius, operation, compute the area of a circle using this formula, library module, utilize the math library, right? Data type float format and all this. Now, this is where the code is being, wow, look at that code as compared to what it had written earlier, right? So once you give it a direction, it does such a nice code over here. So it has done it in a try except, right? So in a try catch block, if you're coming from Java, and it has then taken a input radius 5 and then used this particular function to actually pass it in here and then printed the result. Such a nice code it has written for such a simple functionality. Really, really nice work done by our Llama 3.2. Right, so this is pretty awesome. This is something that I wanted to show you guys, that you can use your large language model, even the smaller large language models like Llama 3.2, 3 billion parameter model, to act like the 70 billion parameter model. I mean, you cannot achieve everything, but if you have a dedicated use case by um, processing your initial request in a particular way, you will be able to achieve a bigger 70 billion parameter model. I mean, kind of, right? I mean, it will fail here and there sometimes, but if you guide your next steps for your AI models, then they may work more closely to your aligned thought process, right? So break it down into smaller chunks and provide guidance to it, is what I'm trying to say over here. All right. So I have already checked in this code. So this code is now updated to the latest dangerously smart agent code. So you can see that I've already updated all these codes over here. And the major change is in the prompts.py and in the agent.py, I think, because there is chat ollama now. So instead of ollama functions, you have chat ollama over here, which is also what is the biggest change, because ollama functions, unfortunately, I think its support is being taken away and it is not being used anymore. And actually, while I'm talking about this, there was an issue raised in my repo that ollama functions isn't really working for some people. And I think that is in the tutorial section over here. Some of these things I've used ollama functions and I haven't upgraded this yet. So this may not work. Some of these things may be broken over here. Whenever I get some chance, I'll fix it. But my priority is not going and fixing these tutorials right now. In terms of my priority, actually, there were some very good suggestions that were given on the comment section of this video. So for example, I saw that there was, yep, this was one of the good project ideas that this guy has provided, Raj over here, that he would like to see some natural language to SQL and SQL to data visualization. Very good idea. I might take that one up. And also this TDD approach. This is also Justin has provided this idea. This is pretty awesome actually, because our agents, I mean, my developers sometimes hesitate in following TDD, but I can make my AI agents follow it more closely, where we can have tests written first, and then we can have so maybe the architecture agent can write some guidance and guidelines and some functional requirements also. Maybe we can have a functional agent. Based on that, we can write some tests, and then based on the tests, then we can write some code after that, and we can have the tests fail with the minimal viable code written over there, and then we can have the test pass after the code is written perfectly. So yeah, this actually would be a very interesting idea to incorporate in the dangerously smart agent. All right. One more thing I want to say, thank you everyone for for subscribing to the channel. I never realized that uh, I I enjoyed having 1,000 subscribers. So I was having under 1,000 subs, and then I went on an India vacation, and a lot changed since then. I was about 800 subscribers at that time, and now I am 1.1k, and it doesn't sound a lot, but I don't know if many of you guys know that once you reach 1,000 subscribers and 3,000 hours of your video being watched in a year, then YouTube offers you this partnership program. And it was really awesome that they offered me this YouTube partnership program. And it feels good. It feels good, definitely. So I'm going to be continuing to make some more videos around enhancing this dangerously smart agent. But at the same time, I also have some other ideas of integrating IoT with AI, and some gadgets that I have that I want to integrate with AI servers also. And I'm pretty sure that in upcoming videos, the content that I'm gonna make, you guys will enjoy and like. So this will be some relatively unique content that I haven't seen floating around online. So keep an eye on the upcoming videos, and definitely give me some more ideas and suggestions if there is something that you guys would like to see. Thank you so much for watching this video, and I will see you guys in the next one.